Welcome, GeoTrig. This is 8-2 Special Right Triangles. The essential question is, what are two special right triangles and what are their properties? Let's begin. So let's think about this. You don't have to write this down. I've got an isosceles triangle here. So x and x are the same length of sides, and then you got side y. What does y equal? So one way to do this is, we have a right triangle here. We talk about Pythagorean theorem. Well, y is going to equal x squared plus x squared and square root of that. Another way we can simplify that is you can say 2x squared. So the square root of 2x squared is y. So if you simplify that square root of 2x squared, you get a square root of 2, and then square root of x squared, which is just x. So y equals x times the square root of 2. And notice these two angles right here, they have to be congruent. They both have to be 45 if that's a right triangle. So y is going to equal x times the square root of 2. Well, this is a neat property, and this is a special type of right triangle called a 45-45-90 triangle. So in this theorem here, if we have two legs that are congruent, we call this side-to-side length, then the hypotenuse is going to be square root of 2 times the length of that leg. So whatever these legs are times square root of 2. So it's a neat property that we use. That's it. We'll do some examples later. Here's another one. Think about this triangle. So I got an equilateral triangle. So this is equilateral. That means all the vertices or angles are 60 degrees and all these sides are equal. Well, what if I have a perpendicular bisector right here? So now this angle is 30 degrees, and this angle is 60, and this angle is 90. This length is going to be side, and this would also be side. What's the length of this side? Well, we know that the length of this side has to equal the length of this total side, so this would be 2s. Well, what's the length of this side going to be? Let's call this x. So x would be, well, it'd have to be the square root of this side squared, so s squared, plus this squared, so 2s squared, which would simplify to s squared plus 4s squared. Actually, I'm wrong with that math. My bad. So if you're looking at a leg here, you get a leg, that's going to be s squared plus x squared equals 2s squared. So that's going to be s squared plus x squared equals 4s squared. I want to isolate the x, so I'm going to subtract s squared on both sides, minus 1s squared. So what you're going to get is you're going to have x squared equals 3s squared. Square root both sides. Your x side is going to equal, well, square root of 3 times square root of s squared, so just s. So this x is going to equal s square root of 3. And this is our other unique triangle here. Special case, the 30-60-90 triangle. In this triangle, you have the length of the hypotenuse is twice the length of the shorter leg. So the smallest leg times 2 equals the biggest leg. And that was the case over here in this triangle. And then the other leg that's in the middle is going to be s times the square root of 3. So the key thing here is make sure it's the shorter leg times 2 is the hypotenuse. And this middle leg has the square root of 3 going on with it. Alright, that's it. Let's do some examples. So pause the video. Alright, so right as reduced radical, we know this is 45-45-90 triangle. So h is going to equal, well, let's do the math on this again. Let's look at that. So we know that s, and then the hypotenuse is going to be the s times the square root of 2. So the hypotenuse is going to equal 9 times the square root of 2. And that's it. That's what your hypotenuse is. 9, this leg, times square root of 2. Next one, pause the video. Alright, similar thing here. So x, your hypotenuse, is going to equal one of the legs times square root of 2. So 2 square roots of 2 times another square root of 2. Well, what this is going to be is 2 times a square root of 2 squared, because we got 2 of them. So that's going to be 2 times 2, which is going to be 4. So x equals 4. Next one. Okay, again, 45-45. So let's see, this one is going to be, x is going to equal, well, we can say x times square root of 2 equals 6 to simplify this. Now, I got to divide both sides by square root of 2. So then you get x equals 6 square root of 2, but I don't like leaving something as 6 square root of 2 on the bottom. You don't want to do that. So you have to multiply by square root of 2 over square root of 2. What happens here is that you get 6 square roots of 2 on top, and square root of 2 times square root of 2 is regular 2 on bottom. This 6 and 2 will cancel to 3 over 1. So x equals 3 square root of 2. Alright, next one. Okay, you have to find d and then write as a reduced radical. So this is a 30, 60, 90 in this case. So d is the baby side and f is the bigger side. Well, we know the relation d, let's see, we're going d times square root of 3 is going to equal that 5. That's the relationship, because that middle side is going to be square root of 3 times that, the littlest side. So divide both sides by square root of 3. And d is going to equal 5 square roots of 3, but we don't like leaving radicals in the bottom, so multiply by radical 3 over radical 3, and that becomes 5 radical 3 over 3. And you know what? We can leave it just like that. That's fine. That's it.